Hey y'all, what we are doing today is extremely important. It's going to help us when it comes to adding and subtracting exponents when you come up and work with me. Right here you'll see my expression. It's in scientific notation. It's 2 5/10 times 10 to the 6th. What I'm going to do today in this video lesson is essentially multiply this by 1. Now if I know that if I multiply anything by 1, I just get the same value. So 2.5 times 10 to the 6th times 1, that's not going to change the value at all, right? 12 times 1 is still 12. 832 times 1 is still 832. 3/4 times 1 is still 3/4. This does not change the value at all. So why am I doing this? You'll see it will kind of change and manipulate this problem a little bit. But essentially, we're going to be multiplying by 1. This is an extremely important lesson. I do need you to take full notes on this one. I need you practicing this because this is not one of those that you can just watch. So I'm going to take this value and I'm going to multiply it by 1. But I'm not just going to put 1. Right now I'm going to put 10 over 10. I know that 10 over 10 is equal to a whole because the numerator and denominator are the same. Just like 5 over 5 is equal to 1. So I'm multiplying it by 10 over 10, which is the same thing as multiplying it by 1. I'm choosing 10 because that's my base of my exponent. And when I'm doing this, what I'm trying to manipulate is my exponent right here. So let's go ahead and do this. 10 over 10 times 2.5 times 10 to the 6th. This is not going to change the value of this expression because essentially we're multiplying by 1. So I'm going to start with the multiplication. I'm going to take 10 and multiply it by 2.5. Anytime I multiply a decimal or any number by 10, 100, 1,000, the number of zeros tells me how many place values I'm going to change. Well, this has 1 0, so that means that this decimal is going to move 1 spot. And I'm multiplying by 10, so it's going to get bigger. So 2.5 is going to move 1 spot because there is 1 0, and that's going to become 25. I have done my multiply by 10, which is this part right here. Now I'd multiplied by 10. In order to keep it balanced, I also need to divide somewhere by 10. This fraction bar means to divide. Now I want to divide by 10 when it comes to my exponent. So I'm going to do that over here. I have 10 to the 6th, and I'll divide it by 10. Now if I'm dividing by 10, what's my invisible exponent? Well, this is 10 to the first power because there's just one 10. So 10 to the 6th divided by 10 to the first. I know that when I'm dividing, I can subtract my exponents. 6 minus 1 is 5. I took the number 2.5 times 10 to the 6th, and I multiplied it by 1, but what I really did was I changed it. This is no longer in scientific notation, but we're going to use things like this for today. So 2.5 times 10 to the 6th is the same thing as 25 times 10 to the 5th. Let's do another one. I have 3 6/10 times 10 to the negative 4th. Again, I'm going to multiply this by 10 over 10. And multiplying it by 10 over 10 is the same thing as multiplying it by just 1. Let's start with multiplication. I'll do this part here. 10 times 3.6. Well, I have 1 0, which means that this is going to change my place value 1 spot. I'm multiplying by 10, so this is going to become bigger. I'm going to move it 1 spot over. 10 times 3.6 is 36. I'm done with that. Now I want to divide by 10. I'm going to divide by 10 over here with my exponent. So I'll put this divided by 10. And it's 10 to the first power. Anyway, you can rewrite anything that's a whole number as to the first power. So 10 to the negative 4th divided by 10 to the first. I know that I can subtract my exponents. Negative 4 minus 1 is equal to negative 5. So this became 10 to the negative fifth. This makes sense. We've worked with this a little bit. We took 3.6 and we made it one place value larger. If I made this one place value larger, in order to keep it balanced, I need to make this one place value smaller. Again, this became 1 larger because 36 is one place value larger than 3.6. So I need to keep it balanced by making this smaller. 10 to the negative fifth, if I look on a number line, negative 1, negative 2, negative 3, negative 4. Negative 5 is farther to the left, so this is smaller, even though it looks bigger. Let's do another one. I'm going to do 6 and 7 tenths times 10 to the 8th power. I'm going to multiply this by 1 again. This time I'm going to make it a little bit different. I know that 10 over 10 is equal to 1. 3 over 3 is equal to 1. So this time I'm going to make it 100 over 100. Now, same thing. I'll do 100 times 6.7. Well, this time I have 2 zeros, which means that this number is going to change by 2 place values. I'm multiplying by 100, so it's going to get larger by 2 place values. So I'm going to move the decimal point 2 spots to make it go from 6.7 to 670. I'll put a 0 in that last place value. So I moved this 2 place value spots. I'm dividing by 100. That's also going to end up moving this number 2 place value spots. So this time I'll divide by 100. So I'll write divided by 100 over here. Now this doesn't work as well. So I'm going to rewrite this as an exponent. I have 2 zeros, which means that this is 10 to the 2nd power. And I know that when I'm dividing exponents, I can subtract. 8 minus 2 equals 6. So this number became 10 to the 6th place value. Again, this makes sense. I took 6.7 and I made it 2 place values larger. In order to keep my expression balanced or the same, if I made this 2 place values bigger, I need to make this 2 place values smaller. These two are equivalent. Last one. I have 8 and 2 tenths times 10 to the negative fifth. I'm going to manipulate this number. It's going to have the same value, but it's going to look a little bit different. This time I'm going to multiply it by 1, but I'm going to multiply it by 1,000 over 1,000. Let's start with the multiplication piece. 1,000 means that I'm going to end up changing this number 1, 2, 3 place values because I have 1, 2, 3 zeros. I'm multiplying by 1,000, so 8.2 is going to get bigger. And it's going to get bigger by 3 place values. I'm going to rewrite it up here, 8.2. So it's going to get bigger by 1, 2, 3 place values, and I'll put zeros in its place. So this is becoming 8,200. Now if I multiply this by 1,000, in order to keep the expression the same, I need to divide by 1,000. This is not a normal way that we usually use to divide. I want to make this into an exponent with a base of 10. It's going to be 10 to the 3rd power because there are 1, 2, 3 zeros in 1,000. So this is 10 to the 3rd power. When I am dividing exponents, I subtract. So I have negative 5 minus 3, negative 5 minus 3. That gives me negative 8. So this becomes times 10 to the negative 8th power. Again, this makes sense. I made this number 8.2 bigger by 3 place values. If I made this 3 place values larger, I needed to make this one 3 place values smaller. And negative 8 is 3 place values smaller than negative 5. You may have caught a trick to do it. Write them out the expanded way, but if you know the trick, then you can use the shortcut. You have the next problems on your packet. If you are still confused, please watch this video one more time. You have the front and back side. Good luck.